something about API design pricing. My name is Honza. I like APIs. I work for Apiary, and I work for Client Community Integer Hobby. Today I'm here to tell you something about what's wrong on classic API design, how to do it better, and how can Apiary help. So how do people design and develop APIs these days? It usually looks like this. At the beginning, there is a guy who says, we need an API. It can be your customer, it can be your boss, but it doesn't matter. You need an API, right? So you go to the meeting room with your colleagues and you design the API. You decide whether it's JSON or Hypermedia or what endpoints or URLs. And that's basically it. When it's done, you buy boxes of coffee and energy drinks, and you go to the sellers and you go and with your developers, you create the API. After a couple of weeks, the API is done. You come up to the sun with the API done, and you present it to the customer. In this case, like front-end mobile developers, and they don't like it. They look at it, and that's not actually what they expected here, because they look at it and say, okay, I wanted to render just this dashboard page, and I need like 200 requests for that. Well, I don't like it. So how to prevent this? Or this whole cartoon could be actually reduced to this. Not good. So what happens here? We design the API, we implement it, we present it to the customer, and customer is not happy. If you look at this a bit closer, you should recognize something you already know name for this. It's known pattern. It's known for 40 years. We know a name for this pattern from 70s, it was amazing age, for instance, for music, especially in Czechoslovakia. And 40 years ago, waterfall model was coined. So for 40 years, we know that this is called waterfall, that we shouldn't use it, and it's bad, and so on. But we still use it. Why? I think the root of the evil is that many people don't realize one thing. I'll show you what. API is an interface. No, that's not what people don't realize. That's pretty obvious from the eye, from the API. But API is an interface to data. Well, that's also pretty obvious. We all know that. But API is an interface to data for client developers. I think people tend to think that at the opposite side of the interface is some sort of machine. And that's not true. There is a client developer, human being, writing the machine, creating the machine. And we should design our APIs for these people. Well, I'm backend developer myself, and usually on conferences or meetups like this, usually people who care about API design are backend developers. Because they have the task, to create the API, so they care about how to do it properly. And they don't actually know any real front-end developers. Those are the guys over the fence. So who are these guys? I'll present you one typical front-end developer. Her name is Valentina. She's front-end samurai, mobile and heavy. She knows everything from JavaScript, CoffeeScript, she knows Swift, she can code from Android, she knows Objective-C. She's perfect front-end developer. And she's human. And well, the same way as when you're designing web pages, you don't design them for the browser. You design them for the user of the browser. So the same way you should design your API for the client developer, the one who creates the client. You should care about the same things as with designing web pages. Like check out Jacob Nielsen. You should care about usability, consistency, error prevention, all these things. And Clientina isn't just human. Or she is human, but she has different concerns than we backend developers we have. I'm a backend developer myself, and I know that when I create backend app, I care mostly about like which framework to use, which language, which database. I care about versioning and so on. But Clientina, well, she doesn't give a shit about this because she cares about examples and a learning curve and about these things. She wants to grab the data from the API, put it into her Angular app, and then if it doesn't work, she wants to debug it. And that's it. And there's also different culture. And I don't mean just like dashes and underscores and cable case and Pascal case. I mean, if you write an app in Java, and if you write an app in CoffeeScript, you definitely use different approaches, different idioms. And you are used to solve problems in different ways. So there's this gap between front-end and back-end developers. And the problem is that you, as a back-end developer, you can't read a book about how to create interfaces for front-end developers in a better way. Or there is an article like top 10 things I should avoid, what not to do to front-end developers, not make them cry. Because every project is different, and every project has different requirements. And so every time the front-end developers, either like mobile app developers or website developers, single-page application developers, they are different. So you can't learn it from a book. The solution is the same as in old software engineering books from the 40s, who said, hey, to avoid waterfall, you should use prototypes and iterations. So the advice is still the same. I have like communication, cooperation, documentation. You need to, basically, you need to make front-end developers part of the design process. So it should look like this. You design the API, then you implement a prototype, then show it to the front-end developers, they give you feedback, you redesign the thing, then you re-implement the prototype, and so on, and after everyone's happy, you end the loop and you present it like first version, and you have a happy customer, happy client developers. But how to do this? How to achieve this? I believe there are many solutions, but the best solution, I think, is API Blueprint. An API Blueprint is a text file in which you describe your API. You describe it in plain text, and you design it. Without writing any code, you just design by writing letters and sentences like what you want to have in the API. And it's also Markdown file. So it's human writable, human readable. You can give it to a tech writer, a documentation writer. They can read it, they can write it. You can give it even to a bishop or a bound singer. And it's text file, it's still text file, so you can version it very easily on GitHub or somewhere. And if you wrote any comment on GitHub or Stack Overflow, you already know what the underlying syntax is. And you can parse it. We have open source parser which can parse the file and gives you like a tree of JSON objects. And from that tree of JSON objects, you can generate, what we do is we generate documentation, for instance. So back to the problem. What API Blueprint does is it gives you a contract. Text file, language agnostic contract. You can edit in a text editor. And by writing this document, from that instant moment, you can generate mock server for front-end developers and get feedback immediately from them. They can start to build applications on top of that mock server from day zero. And once you really approach to writing code, you can, like when you start your Django or Rails app, you can generate test suite. test coverage for the app, so you know that you actually developed something which was designed properly, that you can rely on the contract. So what we are doing here is you design the API in API Blueprint, you write it down, you prototype it with mock server generated from API Blueprint, you implement it with test suite generated from the contract, you deliver it with documentation, and you get feedback and you get back on at the beginning of the loop. And that's the API design lifecycle. And the ecosystem around API Blueprint is large. And it's mostly open source and it's language agnostic. Check it out. And what we do in Apiary is that we provide basically a stack of tools around API Blueprint as a service. What we offer is documentation. Obviously, that's the first most visible thing. Regarding documentation, those who know Apiary already, there was for a long time it was difficult to write to document body attributes. And we sneak peek of new feature. We are introducing MSON, which is a notation in Markdown. You can parse it and you can generate a JSON from it or a JSON schema. We provide mock server, which gives you instant mocks for clients. We provide debugging proxy server, which allows you to actually debug your implementation of live production server by recording the communication and getting diff of what was written in the blueprint and what was in the actual communication, so you can see where the problem is. We have tests you can put in continuous integration. You can test your live production server or local development server, and that is something Adam will talk about in a minute. We have full GitHub workflow, or we don't have it yet. It's also a sneak peek of what we prepare. That you could have one blueprint, like production blueprint, and branch from it, and have development blueprint, and then merge branches and send pull requests, and it will be highly integrated with GitHub or whatever else you would want. And we have sort of enterprise feature of style checking for companies who have 100 APIs. They want to have their APIs consistent, and this is a sort of linter which allows you to check whether the APIs are consistent. For instance, this image says that if you write organization with S in traditional English, and if you write organization with Z with simplified English, you can style check it, and then it will tell you no, this is not consistent. And if you're in, because some of these features aren't publicly available yet, if you are interested in them, or if you would like to give us some feedback, just let us know. We will enable them for you, and we'll be happy to hear any thoughts. And we are also preparing authentication syntax for API Blueprint. In this pull request, it's just in progress. It's open source, so you can be part of the process, or you can just look at it and say, well, I thought it could be better, or something. Give us feedback, drop a comment, we'll be happy. That's basically all I have. Just image credits. Thanks, Leo, for the Virtuvian man. And if you should remember one thing from my presentation, regardless of whether you use API Blueprint or not, please, if you design an API, make your client developer part of the process. That's it. Otherwise, your API will be a failure. Thank you. So questions? Yeah. If you have a good question, I have a t-shirt here. T-shirts. So
So, speaking of making the online developers happy, is it possible to use this sort of thing to create tools for IDs that will provide like autocomplete or real-time error checking in IDs for the client developers?
I probably don't get the like real-time checking of IDs for client developers.
We use this sort of matching the readable description of the API to provide static analysis for the person who is using it, so that they don't have to read the documentation manually, but they can be alerted by their ID, for example, that they type something or.
Yeah, so if client developer writes the client application, he could have sort of like static analysis of the code, is writing, whether it's using the API properly.
Well, I'm asking whether it would be possible to create something like that from this sort of description.
Probably yes, because it's like whatever you write in the document, it's that there, like it's in the parsed tree of JSON objects. Whatever you write there, it's accessible. So, like if you have an idea for a tool which could use anything like that for static analysis, I don't know whether this tool actually exists, but I think it should be possible.
Okay, why did you choose Markdown for the blueprint?
Originally, there was sort of old blueprint format, which was based on curl output. Like if you take curl and make it record the HTTP communication, it was based on that. And there were just snippets of Markdown if you wanted to add some documentation or that. And we evolved from that concept because basically it was better to have the document as whole as documentation, and to give some more like semantics on top of that, and then parse it in this way, so people already know Markdown and they can work with it, and it's not like completely alien format. And it's if you put it on GitHub, it gets rendered just like that. If you edit it in an editor, you can have like linter for Markdown, and it will tell you whether you have like that list or something. So I think it is benefits. You write down in a API Blueprint some like samples of what can be returned, or with MSON you would write just like sort of a schema of the structure, and the tooling would generate the JSON for you, so you wouldn't have to write the payload manually. But as of now, either way it should work. You can write down the JSON which should be returned, and then it will be returned by the host server. And there are some like special features which allows you, for example, if you add one special header, it will return you like error response or something like that. So it's a bit programmable, and maybe in the future it will be more and more programmable host server. Does it answer the question? All right. So I'll give microphone to Ari.
First things first, don't improve this out. I'm glad that I can attend to this special edition in API is only as good as its documentation. If you think it's a cliche, let's think about some really important API. For example, about an API which can save someone's life. When you follow the documentation of this little saving API, which says in case of emergency, call 112. And when you're in emergency, then you call it. And when you didn't get what you expect, it can result with a very bad developer experience of the API, or even worse, in case of this API, it can result in a fatal error. So, what was wrong with this API? Was it bad design, bad implementation, bad documentation, problem in progression? In any case, it definitely resulted in a bad user experience in case of this API in a bad developer experience. Documentation is a user interface for an API, and any error documentation will definitely result in that developer/user experience. And the standard way to correct errors is test. So, when we agree on how important API documentation is, I have a question. How do you test your API documentation? Does anyone? So, I guess you don't. Probably. I also wonder how many people have problem to deploy documentation. And if I consider the documentation is a UI for your API, it's similar to a understand UI. And I hope that nobody does it. And I'm trying to fix this, and this is the reason why you may want to do Draft. This is Draft. Draft is an open source API testing framework made by Apiary, especially or Apiary. And the tagline of Draft project is no more outdated API documentation. So Draft will your body in your fight against bad developer experience and errors in APIs and their documentation. So now I'd like to have a closer look how, and then I will show you a little demo. Have some example with Draft. This is what I call the API lifecycle. API design lifecycle. So this is like the lifecycle of the API, everything starts with new design. That's what Honza mentioned, it's all this like design first thing and interactive verification. And if we do design first, if we write a blueprint, we have like semantic, programmatic, machine readable information about how your API is intended to work. And this is a blueprint for our little saving API, describing what we expect when we call 112. So when we call 112, we expect some predictable response. And now starts the entertaining part, at least for me. Because we have this machine readable specification, we can use thread, which eats API blueprint and automatically tests your implementation. So we can do a local TDD based on API blueprint. And this will be topic of it starts with installation of thread, initialization, and actual construct. This is a description from Apiary, and as you can see, there are like several stages which are this life cycle. And when you're starting your Google DB, this configuration will report to API every result of the test, so you can introspect, because HTTP communication is complex data. You can introspect it better an API in its UI, and this is the purpose of these tests. When you configure the thread locally, and then you push it to Git, thread automatically initialize or modifies your CI configuration. So it's part of your test suite, and it's forever use your API documentation with your API implementation. So if you change anything in the documentation, it will fail. When you change the implementation, it will fail as well, and it will break it all. So this is the most interesting part for me at this moment, because we started to work on testing of the deployed documentation. So to assure that you're exposed to the documentation which is facing to your users, customers, clients, conforms to deployed version of the API. And it's under the live tab on API. I will show it to you. And what's interesting that even trigger live task with a post deploy. So post deploy root in our, for example, our deployment ecosystem or infrastructure. So every time you deploy a version of your API will test your API against your deployed, not intended hidden documentation, which is somewhere in the code, really deployed documentation API, and it can trigger some event. For example, if a PagerDuty incident reported to Slack or somewhere. So this is, in my eyes, fully covered good API lifecycle. What's I'm passionate about is that in API you can have an overview on this overall process and one place. So, people, please. This is API, and this is API, and this is the blueprint. So I have an API. Here is the generic documentation Honza mentioned. Here is some good example, and here's the test step in API. And when I go to the tutorial and follow the tutorial, I will skip this install command, but I will continue with this most important thread initialization command. I will run my visualize interactive configuration, where asks you how you start your API server, so it's your like rails server or Node.js, so however you start your backend server, and it says it under thread file, and then you can see everything under these reports, and it starts with failing test, and then it moves to passing test, so it goes to distinguish between passing test, and then thread reports from continuous integration the same way, like for example, cover waterfalls or any other tools in GitHub. And here is the result of the live test, and that's it. Do you have any questions? Okay.